right, let's do this. Section 1.3. Let's say you're traveling down the road. Everybody with me now? Okay. Watch. Let's say you're right here. You ever go down the road and you see these mile markers? Now, they don't usually look like this, but I'm a terrible artist. Let's say, I'll use the same numbers I did in the other class. Let's say right here you're at the 5-mile mark, okay? And let's say you see the golden arches. What does that mean? McDonald's. Don't you ever stop at McDonald's when you're on a trip? No? Just because it's cheap and quick, usually that's where we stop. Except on this one trip we make when I go to West Virginia for a family reunion. That's where my family's from. And we always stop at the same place. Ever since I was a little kid, we stopped in the same little town in western Maryland every single time. We used to stop at McDonald's, and then they built a Long John Silver. And there's no Long John Silvers around here, and so we eat at Long John Silver all the time. So that's like that one time a year, twice a year, I actually eat Long John Silvers when we go to West Virginia. But anyway, let's say this. Let's say you're going to go here, all right? So you have a sign that says, okay, McDonald's, get off at exit 25. Usually on these highways, the exit numbers correspond to the mile marker. Did you know that? Okay, a lot of times they do. Now, if you go on turnpikes, they don't, but if you go on interstates, for the most part, they do. All right, so let's say we're at exit 5, and we want to go to McDonald's. There's a sign that says you want to go to exit 25. So I can do some quick little math. I don't need a calculator. I don't need to be a math genius to figure out how many miles I have to go in order to go to McDonald's. How many miles would that be? What math did you do in your head? How did you do that in your head? That's right. You did subtraction. You went 25 minus 5, and that's 20. That means you have 20 miles to go, right? From here to here. You could have subtracted the other way if you wanted to. You could have gone 5 minus 25, but that would cause a little bit of a problem. What would happen there if I did it that way? Yeah, you'd get a what? You get a negative 25. But when I talk about distance, do I really care about the negative? No, I could just say, just forget about the negative. Let's just keep the positive. What do we do in math when we just keep the positive version of that answer? Give you a hint.
Absolute value.
Very good. It's the absolute value. All right. So absolute value. And what did I put 25 for? No. Somebody stop me, would you? Somebody stop me. All right. How about 20? That's better, isn't it? Nobody was going to say anything? All right. If I make a mistake, let me know, because it won't be the first time. All right, so we could say 20. It really doesn't matter what order we subtract them in, does it? Now, that's important. I'm saying all this stuff to lead up to something, okay? Lead up to something that we're going to use here in a little bit. It doesn't matter what order we subtract, but how do we find the distance? That's the key. That's the key word right here, distance. How do we find the distance between 2 points? We subtract, that's right. Now, we're just going horizontally here, aren't we? Remember doing your number line, your x and y axis stuff? Okay, this is along the horizontal, so what axis would that be? The x-axis. So here's one way we could say this. Let's call this point x, or let's just call it x1, because I'm going to call all the points on here x's. All right, so if I call this point x1, what do you think I'll call this point? x2. All right, x2, because we're on the x-axis. Not going to call it y. I'm going to call it x. Now watch. In general, how do I find the distance between x1 and x2? I just subtract. Subtract what? x2 minus x1, or x1 minus x2. It doesn't really matter. It's just one might be positive and one might be negative, but you just take the positive version of that. Make sense? Okay, again, that's going to be important. What about if we went up and down? That's right. Okay, so this would be, yeah, we'll call this y1 and we'll call this one y2. So what would be the distance between here and here? It'd just be what? y1 minus y2. Or you could say, if you wanted to, y2 minus y1. It doesn't really matter. You okay with that? That's how you find the distance between 2 points. Now, so far, it's been pretty easy because we've just been going horizontally or what? Vertically. Okay? So in order to find the distance between those 2 points, that's not that big of a deal. Let's do this. I didn't do this in the other class. just because I kind of forgot. But what if we had a point here, 5, and we had a point here at like -3? What would be the distance between -3 and 5? It would be 8. Good. You can subtract it any way you want. I'm going to go 5 minus. Is it 5 minus 3? It's 5 minus -3. And what's 5 minus -3? It's +8. So the distance between those 2 points is 8. If you wanted, you could subtract it the other way. You could go -3 minus 5. But what would that give you? It would give you a -8. It's the same number, right? It's just negative. But what do we do to make it positive? Just absolute value. So it's still 8, right? So does it really matter what order we subtract it? No, as long as we take the positive version of the answer, then we're okay with that. Make sense? All right. All right, we got that? Because distance is always positive. You would never say, oh, I want to go -5 miles, would you? No, you just say, I want to go 5 miles. All right, let's pause this for a second, and let's get into something a little bit more complicated, but it has to do with what we're doing right here. All right, here we go. We got an x and y axis. Okay, x-axis, y-axis. Let's put some points on here, and just for fun, let's make it a different color. What color you like here? Blue.
Purple, red, blue. Purple, green.
I heard blue first. Let's go with this blue. Let's do this. Let's put a point right here. You guys paying attention now? Let's put a point right here. What would that point be? 2, 3. All right. And let's do this. Let's put a point right here. Okay, good. -4, -1. And let's connect them. Because what are we trying to do? We're trying to find the distance. Very good. Trying to find the distance between them. Okay? So we're going to find the distance between here and here. Now this time, it's not just going along the horizontal, is it? And it's not just going along the vertical. It's actually doing 2. Yeah, it is a slope, yeah. But we're not going to talk about slope right now. But we are going to talk about the distance to get from here to here. What we could do. Now, we talked about how to find the distance horizontally and vertically. So we could, let's make this a different color. Actually, let's do this. Let's change it to there. All right, we'll go to that. Is that purple or pink? I don't know. Is it? Watch what we're going to do. We're going to go from here horizontally. Oops, I'll have to scooch it up a little bit to there. Okay, it's close enough. So that would be horizontal, wouldn't it? That looks like the same color as that, doesn't it? Tell you what, let's make this
Black.
Let's make it green. All right, you can barely tell. But anyway, there you go. All right, so we've got that. We've got that distance. Let's talk about that for right now. Let's where are we on the x-axis at this point right here? Just think of going across. Where are we on the x-axis? We're at -4, aren't we? Where are we on the x-axis here? We're at +2. Because I want to go, remember, we can only find the distance left and right and up and down. So I want to go from this point to this point. How do I get from here to here? Well, I go across, and then eventually I'll go up. So I want to find the distance across, and then I'm going to find the distance up. Okay? So right here on the x-axis, that's at -4. Where is it here? No, just that point. Just that point. It's at 2, isn't it? And I know what you're getting at. How do you find the distance between here and here? We went through a whole thing. We went through a whole thing. Subtract, right? We subtract. So what do we subtract? 2 minus -4. Good. And what is 2 minus -4? It's 6. It's +6. What's that length from here to here? It's 6. Okay. Now, watch this. Now let's go up. Awful, just a little bit, but you get the idea. All right, you already saw that, right? So look, what is it? Yeah, it's at 3. Yep. So look at the point. Where are we on the y-axis right here? We're at 3, aren't we? Where are we on the y-axis at this point? We're at -1, aren't we? Just on the y-axis, just up and down. How high are we? We're at 3. How low are we? We're at -1. Does it make sense? So what's the distance between -1 and 3? Well, it's -1 minus 3. I did it like this for a reason. What's negative 1 minus 3? It's negative 4, but we always take what? You always take the absolute value, which is what? 4. Okay, so what's the length, what's the distance from here to here? It's 4, isn't it? You follow me?
Yeah.
Now look what we're going to do. What do I want to try to find? I want to find not just any old distance, what? The distance between this point and this point. Now look what I have. I've got a triangle. Do you see the triangle? Okay. Tell you what, give me just a second. Let me try to make this. I'm going to pause this. Yeah. What I did is I just recopied this triangle, put it off to the side, just so we don't have all the junk all around it. Is that okay with you? All right, so what do we got? What was the length of this thing right here? It's 4. What was the length of the bottom? It was 6. Now, this is a right triangle. How do you know it's right? Because this is horizontal and this is vertical. Okay? How in the world can we find that right there? It is the hypotenuse, you're right. But how do we find it, though? You probably say it. Zach. Watch. A squared plus b squared, what? You remember that from Algebra 1, don't you? That's an Algebra 1 topic. And what's it called? Pythagorean Theorem. It's a weird name, isn't it? Pythagorean Theorem. Named after a guy a long time ago. His name was Pythagoras. Yep, Pythagoras. All right. It's his name. What does Javon mean? I don't know. I don't know. What is Pythagoras? Is the dude's name? Who knows what it means? Anyway, but we named it after. A lot of talking going on. Let's pay attention. All right, look. He's probably from Greece. It would be my guess. Yeah. I looked him up at some point. I forget. I mean, you could look him up if you want. But his name's Pythagoras. He came up with this thing, a squared plus b squared equals c squared. Let's actually do that and solve for this distance right here. Because that's what we're trying to find. We're trying to find the distance, right? We found the horizontal distance. We found the vertical distance. Now we need to find this distance right here. That's what we were trying to find in the first place. So I've got 4 and 6. What do I do with those numbers? Let's do it up here. Let's do the math up here. 4 squared plus what? 6 squared equals, let's call this d for distance. Is that all right? Instead of c. So we'll call it d squared. All right. Let's do this. That's 16. That's 36 equals d squared. What's that? 52 equals d squared. Now, if I want to solve for d, what do I do?
Square 52.
Square it? You sure you want to say square it? Unsquare it? There's a better word. What? Square root. Good. It's the square root. So watch. Take the square root of this side. Take the square root of that side. So what's d equal to? The square root of 52. And we'll just leave it like that. You can simplify it. I'm not going to get into that right now. Okay? We'll just leave it the square root of 52. So that right there is the distance between this point, 2, 3, and this point, -4, -1. There's got to be a better way than just to draw this thing out every single time. Wouldn't you think? All right, so let's do this. Let me pause this. We might be able to fit this in one lesson. We'll try. All right, so what I'm going to do here is I'm going to redraw another. Let's put a point here. I don't even care where it is. Put a point right here, and I'm going to connect them. All right, let's make those points. Oh, I know what. Let's make that point right here. I don't care where the points are. In fact, I don't even care where those numbers are. Okay, what I'm going to do is this. I'm going to call this point x1, y1. I'm going to call this point, what do you think? x2, y2. Now watch what I'm going to do here. I am going to, remember what we want to do? We want to find that horizontal distance, right? And then we want to find that what? That vertical distance. Let's scooch that over. Sorry about that. I don't think I'm going to finish, am I? Before 15. So watch what we're going to do. I want to find the distance from here to here. So how do I find the distance? This is one x point, and this is the other x point. What's the x point here? It's x2, isn't it? You see it? It's right under here. So how do I find that distance, this bottom distance? It's x1, what? Minus x2. How do I find the up and down distance? It's going to be y1 minus y2. All right, I'm going to have to wait and go to the next video. Sorry.